So now we're going to talk about applying unsupervised learning techniques to healthcare data. And to start, we're going to just talk about what unsupervised learning is and how it works. So firstly, what is unsupervised learning? Well, as the name suggests, it means learning without supervision, which really means learning without human supervision. And what that means is you are looking at things that don't necessarily have a right or wrong answer and haven't had a human mark them up as right or wrong or categorized in some way. So unsupervised learning is any attempt made to extract information about the structure and sources of variation in a data set that doesn't have some kind of labeling. There is no correct answer or variable you are trying to predict. The idea is to understand the internal structure, much like an observer in the real world with no pre-existing knowledge. So unsupervised learning techniques are much like humans who, when they get into a novel area or a novel data space, just try to graph things out and look at what the trends are. Why do we need unsupervised learning in healthcare, right? Unsupervised learning sounds vaguely dangerous or vaguely careless or sort of second rate. That's actually not true at all. It, for starters, mirrors the way clinicians think and make new discoveries, right? So when clinicians are encountering new populations or new sort of associations of illness, their first thing they do is just sort of look at the data set as a whole and see what jumps out at them. Or maybe they begin to form hypotheses as they see individual patients and they begin to realize over time, some of these patients are related to others, even if I don't know why. That's exactly what unsupervised learning does. Because healthcare is so messy, we don't always find out what happens to patients. It's actually very useful, particularly in healthcare, to have methodologies that don't require a right answer or end of the story, because often even the clinician doesn't get an end of the story. If you're an emergency room clinician, perhaps you saw a patient, recommended that they take certain actions, you don't actually know if they did. Or if you are an epidemiologist with some sort of survey data, and perhaps you go to the same neighborhood over and over and survey people to see how perhaps their environment is affecting their health, many of those people will move away or move into the neighborhood or just stop talking to you for one reason or another. You need to be prepared for data that doesn't have a right answer and doesn't have a neat story. Unsupervised learning handles that very well. And finally, unsupervised learning doesn't require expensive human annotators. So much like we've discussed earlier, for example, with natural language processing, sometimes if you really want to get an answer, you need a human annotator. But sometimes you don't have the budget for that, or sometimes it's just not important enough. So unsupervised learning can be very helpful for learning as much as you can without a human annotator. One form of unsupervised learning, although not the only one, is called clustering analysis. This is a very common way to begin exploring a data set and even making useful conclusions from that data set. The idea of clustering analysis is to identify relatively homogeneous groupings of data points. Often in healthcare, that's going to be homogeneous groupings of people. Intuitively, this reflects how we often see the world organizing itself. There tend to be sort of different types of people or different types of patients whose behavior or clinical indicators show them falling into relatively distinct categories. So coming from the mobile health space, I can tell you that it is very common to see users versus super users, and there tend to be certain attributes that cluster. For example, super users tend to have smartwatches. Non-super users tend not to have smartwatches. There also tend to be trends, say, in demographic variables like gender or age, and those things tend to cluster as well. So just like we see in social categories that people tend to have more in common with certain kinds of people, we see the same thing in health data. The kind of clustering we're going to look at right now, just as a quick demo, is called k-means clustering. The intuition is we want to create groupings such that the variance within the group is minimized. So we want to create groups so that the people in the group are as much like each other as they are, or that the data points in the group are as much like each other as possible. The constraints on k-means clustering: the first is you have to pre-specify the number of groups, which can be hard to do when the whole point is that I want some insights, right? So I don't know, say, how many kinds of users of my health app there are. I kind of want to find out, but with this algorithm I have to decide in advance. There's also not a guarantee that I will get the exact same results every time. This is not a fully deterministic algorithm, although you will find most of the time you will get approximately the same results. So the second constraint does not tend to be a big problem. So we are going to go into a code demo where we will see how this works in practice, how we can take big rectangular data sets that a human cannot possibly process, certainly in a reasonable amount of time, and we can quickly figure out whether there are distinctive groupings within that data set.